Hello, I welcome you once again to another clip on Secant Method. And this is the third clip on Secant Method. This time around, we want to try as how best we can be able to create a simple function that we can use it over and over and over on under Secant Method. So let's dive into it. First of all, let's look at one of these functions and how we can solve it. We can find the root of this function under this script. So first of all, we'll run the script and it's asking us to supply our initial guess. So first of all, we'll be looking at the second function, of which our initial guess, we have to choose values within this interval. So I happens to choose 0.2, let me choose 0.3. Okay, and my function name is I choose, first of all, I have my @ sign. I don't need to forget that one, and I leave a space. X times exp times the exponential, supply the x minus 1, run it, it's tolerance 0.01, it gives you my root that I was looking for. So from here, we want to change the entire thing into a function. We want to change this whole thing into a function. So to change it to a function, first of all, we have to write a function here up there. Function, and then we have to call the function, write the function name must be the same as what we have. Secant tutorial. So we want to supply our function, which is our f, our a, our b, and our tolerance. Yeah, those are the arguments that we'll be supplying. So since we have this one, the function, we need to end it here. Okay, so from here, we don't need all these ones, we don't need these ones here, we don't need them here, so we just have to suppress them, or better still, boom, comment them. Better still, then we just clear them off. So from here, we happens to get something simple that we can visualize. So first of all, we have to write our screen. We have our function nicely written. Then we can call, since it's a function, let's first of all save it, and then we call the function name. Call the function name like a tutorial. So yeah, it's asking for our f, which we already have the f as a function. We have our ba as a function, as a value there. We have our ab, and then our tolerance. We can still enter the tolerance here in case we have not written that one, and then we just enter it simply. Then it has given us the root that we are looking for, the approximate root under consideration. So let's look at another case. We want to solve for the first function. So we have our f to be equal to our root. You can decide to bring a bracket or not, doesn't change anything. Minus our 2 times our x minus 1, just to make it look nice. we can suppress it. We have our a, let's say we choose our a value to be equal to we are choosing values within here, so we choose our a value to be 1.5. we suppress that one. We choose our b value to be 1.8. Let's try that one. And then we have to supply our tolerance. So we choose our tolerance of 0.001. Okay. Then we call the function. We call the function secant tutorial. Supply our f, a, b, tolerance. I think I've written it right. Okay, let's see. So we happen to get our approximate root to be 1.618. So this is a simple function for the secant method, and it works perfect. And we have come to the end of these tutorials. If this video happens to be of help to you, don't forget to subscribe, like, and comment. Thank you.